All right, in this question, we have begun to link the periodic table with these quantum numbers and electron configurations. And so first thing I want to do is find arsenic on the periodic table, and I see that it has 33 protons. And so we can write the electron configuration for arsenic. And so that would be, I'm going to write the full thing, 1s2, 2s2, 2p6, then we go to 3s2, then we go to 3p6, and up to 4s2, and then back down to 3d10, and then we have 4p. So we're at 2, 4, 10, 12, 18, 20, 30. So we're going to have 3 left. Now, remember, previous we had N levels, L, M sub L, with multiple orbitals in each, and then each orbital can hold 2 electrons. Now we're seeing that with the plus and minus 1/2. So let's look at the problem. The possible answers have everything is in 3 or in 4. So that's what we're focusing on. So we're going to kind of draw a line here and focus on the 3s and 4s. And so what I'm going to do is identify them, right? So if N is 3, then L can be 0, 1, or 2. Now, if L is 0, then N sub L is 0, and that is an s orbital. If L is 1, then it can be -1, 0, and 1. That is a p orbital. Now 2, -2, -1, 0, 1, and 2, and that is a d orbital. So s's have 2 electrons, p's have 6, d's have 10. Remember, 2 in each. And so let's look at n equals 3. So we have an s, so that's L is 0, here it is 1, and here it is 2. Now we can also look at the 4s, same thing. So for the 4s, the L is 0 here, and we have some in the 1. So L can be 0 or 1. So what we're going to look for in this problem is, which one of these does not work. And this is in the ground state, so something to be aware of, because excited means it could have anything up higher. We don't know where it's going to be if it's excited. So this is ground state. And so here we have N equals 3 and L equals 1. We see that here, so that's good. Here we have N equals 4 and L equals 2. So already we're looking at an issue. So we got 4s, but we have no L equals 2. That would be a D, that would be 4D. So this one's looking not good. So let's keep going. We got 4 and 0. Notice all the MLs are 0, which means it's just they're picking one that's right in the middle of the L. And so 4 and 0, we do see this, which is good. 3 and 2, so here's that one. That's a d orbital. And 4 and 1, which we see right here, which is a p orbital, and it can have one in there. Because remember that those p orbitals, it would fill them. So there'd be 1 in the -1, the 0, and the +1. And same here with the s orbital. So the only one we have an issue with here is B, where we have, it's saying there's a ground state electron in a d orbital, which is not possible. We don't have enough electrons here. So I'm going to select B. There we go. So all of these type of problems are ones where you just kind of got to work through it. And it's really, the goal here is really to get you to understand these quantum numbers and how they relate to electrons and how they relate to the periodic table.